So let's look at the last use case here. The last platform use case here is scale deployments to zero. Now, this isn't really about things like event-driven auto scaling. This is more about, from an operator's perspective, you getting automated help that you need to be able to know what to do next or just to assist in some of your day-to-day jobs. So here's a common problem. You have a deployment that's managing pods and something happens and those pods continually restart. They go into crash loop back off. And as you probably know, Caverno is going to continue to try and restart those on a periodic basis. Very often, though, depending on the problem that happens, no amount of restart could be potentially useful. Of course, that depends on the situation, but in some certain circumstances, they're just going to endlessly come into be scheduled, go into a running state, maybe immediately or at some point in the future crash, and then that cycle is just going to repeat ad nauseum. What we can do is help use Caverno to help us identify those. And if that situation is happening on a threshold which may be too much, we can have Caverno scale that deployment down to zero and also tell us about it in some way, marking that we need to do some additional troubleshooting. But the reason why this is especially helpful is that it doesn't create that additional pod churn. And if this is happening across multiple deployments in a cluster, that pod churn could be fairly significant. So if this is happening, if this restart process is happening too much, Caverno can observe that. And that's exactly what we're going to show here. So we've got a deployment that is spawning one or multiple pods, and something happens in that pod. There's a problem, and it's restarting. And in this case, I'm just going to set the threshold to 3. You can imagine this could be anything, but the pod, if it restarts any more than 3 times, we know that something's gone wrong with it. Further restarts aren't going to help it. We need Caverno to help us out here so that we can take action on a later date. So Caverno is going to be deployed and it's going to observe that event happening. And when that happens, it is going to scale that deployment down to zero and also annotate it so that we know from a platform perspective, and we might pick this up in our monitoring tools, hey, this is now with 0 replicas. It's because something's happened. Let's take a look at it. So let's flip over and do that. Let's take a look at this. Now, again, we need to grant Caverno some of those additional privileges that I mentioned, because just like in the second use case, we need to update deployments. So since I've removed those previous resources, I need to put that cluster role back in place. And again, same thing with the role aggregation. That's what we're doing here. So we've given it those permissions. And now I'm going to create a deployment and back to our ye old busy box. This time it's going to sleep for 10 seconds. So after that sleep cycle is done, it's going to cause the main process to exit, which is in turn going to have Kubernetes try and restart it. So it's just going to sit out there and run, and we're calling it distress busy box. It's going to sleep, and then after 10 seconds, it's going to restart. And so here's our Caverno policy. Now, this is a little bit more involved, so I won't walk through all of this, but this is just an illustration of some of the power that's capable of in Caverno. And as you can see, there's no programming language that's involved here if you're familiar with things like variables. And as we showed with previous policies, some of the existing constructs and patterns with which you're likely using today, then you can probably parse this. So we'll just a couple things to point out here. Caverna has the ability to look at sub-resources. So we are looking at the status sub-resource in a pod. We are checking for updates to it. And here's where we're going to define our update count. We want to see any restarts, anything that's greater than 2 is going to trigger this policy. Now, a pod is going to define an owner as a replica set in the case of a deployment, and we need to be able to identify the deployment. So we're going to use what are called context variables in order to ask the API server to build that chain back up to the parent. So we're going to find the replica set name, and then we're going to ask the API server, hey, give me the deployment that corresponds to that replica set name. That'll give us the deployment. And then from there, and that's stored in deployment, we will be able to once again mutate existing deployments, not new deployments, because we already have a deployment that's out there and running. We will mutate any existing deployment that is met by this, and we are going to put the replica count to 0. And we're going to write our sre.corp.org/troubleshooting needed annotation set to true, which will allow us to pick this up in a monitoring tool or some sort of reporting tool that we might be using to identify, hey, it's not just set to 0 replicas because something like Kita, for example, was in the cluster and it scaled it to 0 because there wasn't anything to do. It's because there is an actual problem and somebody really needs to look into this. So let's go ahead and create this cluster policy. And now that that's in place, let's create the deployment, which is going to sit out there and run a BusyBox container in a deployment, and it's going to sleep and therefore restart every 10 minutes, every 10 seconds. So what we expect to have happen, and I'm just going to watch the deployment here. We're going to watch the deployment. We've currently got one replica. And now what we expect to have happen is this deployment count getting set to 0, and that's going to indicate that Kyverno has observed the 3 pod restarts, and it has backtracked, found the replica set, which is defined as part of the pod, and then looked up the deployment that corresponds to that replica set, scaled the replicas by setting that field to 0, and also added this annotation to it. So let's just watch for a moment here more. As you can see, the oscillation between 1 of 1 and 0 of 1 represents those pod restarts when our sleep period of 10 seconds has ended, and so therefore Kubelet's going to attempt to restart that and give us another sleep for 10 seconds, but it's just going to do this over and over again. And on the next one, once this occurs, it's going to observe that, and as you can see, that's just happened here. It's now set the number of replicas to 0. So there should not be any pods that remain from this because it scaled it to 0. Let's just check. It could be in the process of terminating them, and it's not. It scaled them to 0. Now let's just check one last time. Let's take a look at the distress BusyBox deployment and see that we actually got what we expected. And so let's scroll up here. And as we can see, we got replica count of 0, and we got our annotation informing us that somebody needs to get in here and do some troubleshooting. All of this happened in an automated fashion that you defined as policy without having any code that's defined in there, and Kyverno was able to take care of this. So with that, that is the end of the demo and the end of this recording.